start with the housekeeping note. It disappears. So don't worry. I will start the session, and I will start the recording now. So, good morning, good afternoon, good evening, ladies and gentlemen. My name is Eisak Todo of the Minamata Convention Secretariat, and I'm glad to convene this last session of the Minamata Online Season 2. And Season 3 will be launched in summer. The Minamata Online is started in 2020 as a series of online events, and its season 2 started in 2021, last year. And it consists of 3 streams. One is science stream. The second is the implementation review and support, and the third is the preparation for the conference of the parties. The science session, a science stream is co-convened or co-organized with the International Conference on Mercury as a Global Pollutant, ICMGP, which will meet virtually this year from 24th to 29th of July, and in person 2 years later in Cape Town. So we don't have a participant representative of ICMGP, but I would like to convey you the best regards from the ICMGP organizers. Since the agenda seems to be packed, I don't speak. I don't spend too much time, and I immediately hand over to the the moderator of this session, Ms. Hayashi. Over to you.
Thank you, Toda-san. Hello, I'm Yayoi Hayashi from the Overseas Environmental Cooperation Center, OECC, Japan. It is my honor to be your facilitator today. And let us welcome today's presenters. The first presenter is Mr. Mick Saito from United Nations Environment, and I briefly introduce his profile. Mr. Mick Saito is Program Management Officer of UNEP Asia Pacific Office with special expertise on chemical and waste management. And he joined UNEP to implement a Japan-funded Mercury project, which promotes the Minamata Convention on Mercury. Before joining UNEP, Mr. Mick was with the Ministry of the Environment of Japan, where he was deeply involved in the development of mercury management and SAICAM-related chemical policies. He was the bureau member of the first and the second corps of the Minamata Convention. So he will make the introduction to start today's seminar. The second presenter is Mr. Koichi Haraguchi from National Institute for Minamata Disease, Japan. And Mr. Koichi Haraguchi is Mercury Analysis Technique Section Chief, Department of International Affairs and Research at the National Institute for Minamata Disease, Ministry of the Environment of Japan. His works are dedicated to mercury biomonitoring, including the development of reference materials for evaluating the accuracy of mercury analysis for human biomonitoring. He is one of the leading contributors to support countries in strengthening their systems for monitoring health issues associated with mercury pollution. He has won several research funds from the government, including a review on the health effect of methylmercury exposure. So his topic today is laboratory proficiency testing for mercury, strengthening mercury analysis capacity, meeting international standards. And the third presenter is the third presenter is Mr. Minoru Koga from Minamata Environmental Academia, Japan. He is director of Minamata Environmental Academia in Minamata City, Japan, since its establishment in 2016. The academia is a knowledge hub for Minamata through research and higher education activities involving university and postgraduate students, government officials, and environmental engineers from Japan and abroad. It hosts a number of environmental training courses in collaboration with the UN agencies. Mr. Koga is an expert in environmental chemical analysis and Professor Emeritus of Prefectural University of Kumamoto after serving as president from 2010 to 2016. His topic today is Virtual Laboratory Assessment Methodology, Innovative Approach under COVID-19 Setting. The fourth presenter is Miss Kania Dwi from Institute Technology Bandung, Indonesia. She is head of the undergraduate study program in environmental engineering, faculty of civil and environmental engineering at Institute Technology Bandung. She is also a lecturer of the undergraduate, graduate, and PhD programs of that same faculty. She is an expert in air quality monitoring, modeling, impact assessment, and control. She is one of the most active resource persons in Indonesia in the field of mercury management. In 2021 and 22, she served as a country facilitator in the UN organized training sessions of mercury mass flow. And her topic today is mercury inventory and mass flow analysis, improving national mercury inventory in Indonesia. The last presenter today is again Mr. Mick Saito, once more, and he will present on comprehensive mercury survey for soil waste disposal facilities, results and challenges. And after each presentation, we plan to have about 5-minute Q&A. We would like to invite your questions and comments, so please use the chat box and send it to everyone. Now, let us proceed to the introduction. The speaker is Mr. Miksaito from UNEP. So you have the floor, please.
Okay, thank you very much, Hayashi-san, for the introductory part. So today, this session is mainly, by the way, could you start sharing up the screen? Yeah, yes, please. Today's the session mostly the result of the Japan-funded the project that I just briefly introduced in 5 minutes in this opportunity. So please, next slide, please. So in 2019, UNEP and the Ministry of the Environment of Japan agreed to implement the project for promoting Minamata Convention on Mercury by making the most of Japan's knowledge and experiences. So the two directors actually met together and signed the contract. Next slide, please. So this project has 3 key features. First, this project had the special focus to contribute to the Minamata Convention, particularly in Article 17, 18, and 19, their information exchange, awareness, and also research, development, and monitoring. And the second is that we are developing the special relation with the Minamata institution in or around the Minamata areas. So today we see the institution, the participants presenter from the Minamata area. So we call it the connecting the Minamata city and the Minamata convention. This is the very unique feature of this project. The third, this project will establish the network of the analytical institutions to strengthening their Mercury analytical capacities. So these are the three key features, and we are implementing a number of activities. Next slide, please. So we have 12 partner countries in the left-hand side in the circle. And in addition, we have the partners I just mentioned, a special relation with the Minamata institution in Minamata. Already introduced by Hayashi-san, Minamata Environment Academia, and the National Institute of Minamata Disease. They will make the presentation in this webinar. Also, we have collaborative activities with the APMMN, Asia Pacific Mercury Monitoring Network. So these are the organization and partner countries that the UNEP is working with. Okay, next slide, please. The project had a 5-year implementation period. So in the this is the work plan that you can see on the left-hand side. And we are 2022, so the yellow dot line is just where we are now. So we are now in the middle of the implementation. We have mainly the big 3 outputs. And output 1 is the capacity building components. So it includes the training online or face-to-face training and the material, training material, developing the it's the main deliverable for the output 1. And you can see we are in the middle way. So comparing with the other 2 output, this output 1, it somehow we are making the good progress. We are almost more than 50% implemented, completed. For output 2 is the monitoring components that we are engaging the Mercury monitoring or analytical institutions, assess the capacity and strengthen the capacity and conduct some Mercury monitoring survey or such a continuous data collection of the Mercury in the environment. So this is the one of the key activity for this project. And the third is outreach or technical information collection. Get the information and disseminate into a wider audience. So this webinar today is also the one of the activity falling under this output 3. In addition, we are getting the technical information relevant, especially for the developing countries and the partner countries, including partner countries, and uploaded into our website and make it available. So these are the overall picture of this project, and we will have a few results, ongoing results that we will share with you this opportunity. Next slide, please. That's all from my side. So thank you very much, and we can proceed for the next presentation.
Thank you, Saito-san. So we move on to the first topic by Mr. Haraguchi. So Haraguchi-sensei, you have the floor.
Thank you, Hayashi-san. Hello, everyone. I'm delighted to give a talk today. It's a pleasure to share the highlight of an external quality control survey provided by UNEP LOA. The first round of Mercury laboratory proficiency testing aims to evaluate the Mercury analysis conducted by the laboratories. Next slide, please. In this presentation, I will first talk about the outline of the proficiency testing program and its benefits, and then I will share the preliminary result and wrap up with a corrective action. Next slide, please. Proficiency testing is conducted to confirm the laboratory's competence by an inter-laboratory comparison using a subsample from the homogenized material. Test items are usually distributed simultaneously to the participating laboratories. They are not informed how much of the substance is contained in the testing item. After the measurement according to their standard operating procedures, the coordinator compared the received individual's result with an assigned value to indicate their performance. And briefly, if a participant's reported values are similar to those of many other participants, they are considered satisfactory. On the other hand, if the reported values are different from others, they are deemed unsatisfactory. Participants can see a test performance trend in the feedback report and compare it with other laboratories. Even if unsatisfactory rating this time, regular participation and ongoing corrective actions are considered to be evidence of satisfactory execution for laboratories. Next slide, please. The importance of data quality was recognized again at COP4. According to the information document, quality practices are necessary to help ensure that monitoring results are valid, free of bias, and comparable across studies and regions. In addition, the following were recommended: using appropriate reference materials, participation in inter-laboratory comparison programs, and reporting on analytical parameters such as detection limit, accuracy, and precision. UNEP has decided to conduct a proficiency testing this year as an inter-laboratory comparison program. Next slide, please. First round of Mercury laboratory proficiency testing provided by UNEP aims to evaluate the Mercury analysis conducted by the laboratories. It gives their proficiency levels and collective Mercury monitoring capacity in Asia and Pacific. The target group was public laboratories and laboratories in universities that undertake Mercury analysis or will undertake it shortly. The fee was free for all participants. The requirements for analytical qualification is that the limit of detection is less than 1 nanogram mercury. It corresponds to 0.1 ppm of hair relative to a 10 milligram sample. A provider is UNEP and NIMD, National Institute for Minamata Disease, was responsible for proficiency test design, and AIT, Asian Institute of Technology Regional Resource Center, organizes laboratory engagement and sample distribution. And IDEA Consultant Incorporation operated the testing scheme, including preparing items. Next slide, please. In October 2021, UNEP Pro-Up called to participate in the proficiency test by the annual webinar on Mercury science. Registration began the same month on the website, and test sample distribution started from February 11th until March 7th. The report in Excel format was sent by email. Participants were instructed to analyze total mercury 3 times according to their SOPs and report all 3 results. The deadline for reporting result has been postponed 1 week to April 7th due to shipping delays by the pandemic. We have almost compiled the result. We will provide feedback to the participants and notify the statistical result in August. And the details on how to prepare the test items are as follows. Human hair was collected from the Japanese, washed with detergent and sterilized by gamma ray. The sample was cut finely and mixed to ensure sufficient homogeneity. Homogeneity was confirmed using 10 samples randomly selected from 100 sample bottles. After reporting all participants, we analyzed the other 10 stock samples to ensure stability during the testing period. Next slide, please. The number of participants is shown in this table. 34 laboratories were registered. Due to logical delays and tighter border controls for human samples caused by the coronavirus, 3 laboratories could not be received test items. Finally, 26 laboratories ended up delivering result. It's 3/4 of the total numbers of registrants. The most significant participants were from Asia, followed by Africa and America. Next slide, please. What you see here as a result of mercury analysis by individual laboratories. Each result is described in laboratory code. As shown here, the outliers were relatively small. Therefore, the assigned value of 1.46 milligram per kilogram was obtained from the median of the participants' value. Uncertainty of 0.12 milligram per kilogram was calculated from the normalized interquartile range. Next slide, please. Z-score for each participant's result was used as a performance valuation data. Z-score tells us how many standard deviations above or below a data value are from the average. For example, if the Z-score equals +2, it is 2 standard deviations above the average. Performance indicated by Z-scores is based on the following criteria. Between -2 and 2 in green color is regarded as satisfactory. Above 3 or below -3 in red color is viewed as unsatisfactory action signal. Likewise, the yellow one is considered as questionable 18 of the 26 laboratories reported satisfactory outcomes. It is 69% of all participants. Next slide, please. This figure shows the analytical method used in analyzing total mercury in test item, their mean values, and satisfactory rating as indicated by the Z-score. There were 4 methods employed for analyzing test items. The most frequently used method was thermal decomposition amalgamation atomic absorption spectrophotometry, sometimes called direct mercury analyzer, and followed by cold vapor, CVAS. Cold vapor atomic fluorescence spectrophotometry and ICP mass were employed in 2 laboratories, respectively. Thermal decomposition amalgamation method achieved good performance. 13 of the 15 laboratories reported satisfactory result. Conversely, 3 of the 7 laboratories reported satisfactory data derived using cold vapor AAS. It is challenging to interpret the result of the bias of the method employed due to the limited number of laboratories participating. But unlike other methods, thermal decomposition, atomic absorption spectrophotometry, does not require acetization, filling a volumetric flask, and transferring fixed volume to the reaction vessel. Its simple operation may make it easy for analytical staff to run in a short period. However, these factors work to increase random errors, not one-side bias. Next slide, please. The summary is as follows. 26 laboratories analyzed human hair, and 80 laboratories had a satisfactory outcome. 22 laboratories participated from Asia Pacific. 4 methods were employed, and almost all laboratories using a thermal decomposition amalgamation AS obtained satisfactory result indicated by Z-score. And the next slide, please. So we should provide comparable monitoring data to strengthen the scientific evidence for the effectiveness evaluation. Regular participation in external quality control is a part of the activities of producing comparable data. In addition, laboratory needs their own SOPs and ongoing internal quality control. Good SOPs are easy to understand for your staff and include criteria for determining whether the measurement is ongoing successful. I don't know if my SOP written in Japanese is a good example. I believe you can see that this illustrated instruction provides how to complete an analysis step by step. Each step has acceptance criteria, for blank, slope, precision, and recovery sample. In addition, there are instructions for recording the output in the logbook. The outputs are intakes QC chart and monitors for changes in random errors. To minimize bias, it's helpful to measure appropriate certified reference materials. NIMD provides reference materials for human biomonitoring samples, hair and urine. They are provided free of charge to laboratories of universities, public institutes, and private research institutes that perform chemical analysis related to the Minamata Convention on Mercury. If you would like to apply them, please access our website. Next slide, please. That brings me to the end of my presentation. Thank you for your attention.
Thank you very much, Haraguchi sensei. And we have one question from actually Toda-san of Geneva Secretariat. His question is seen on the chat box. We know several comparisons of air passive samplers or water samples, but good to hear that we have reference hair samples now. Can they be used in the future lab enter comparison? And Haraguchi sensei, could you provide us a brief answer to that?
Can they sorry.
Can they be used in future lab into comparison? Like the proficiency testing results at this moment, we have some results already. So do you think we can use that in the future lab?
If I may, my question is that, you know, in the future there will be need for human the analysis of human samples. So if in future if we need a kind of quality control of human biomonitoring, do you think that the human hair samples, the reference samples, will be useful for that exercise? Thank you.
Thank you, Toda-san. Yeah. Our reference materials and this test items is very useful for the laboratory quality control, and also proficiency test will be carried out regularly. I'm afraid I cannot give any definite answer at that moment, but next sample may be vital or environmental samples near future. Thank you.
Thank you very much.
Thank you.
I want to add the one additional comment that UNEP, ROAP, and the National Institute, it's now considering the second round of the proficiency testing this fiscal year. So this is not the one-off exercise, but the annual event that we continuously support the laboratory to improve their performance. So this is the our intention that this is the very first time that we are introducing our effort, but we want to invite more laboratories to join this exercise for the next time. Next time in this year.
Regular participating into the proficiency test is useful for quality control. Quality control. Yes.
Thank you very Yeah, go ahead.
Let me answer the briefly the question I just get from the chat box. For the participation for the proficiency testing. Last year we called for the expression of interest. So the participant will express the interest, mean send a message, send an email to the respective email address, so that procedure starts. our participant is the public laboratories like the National Institute, the local government, Institute of Local Government, or universities, not including the private sector, private laboratories. But if it meets the criteria, mostly the participation will be granted, and it's free of charge. So please be aware about our announcement for the expression of the interest.
Okay, thank you very much for the interventions. And well, it is almost the time for the next presentation. So we would like to invite Koga Sensei. The floor is yours.
Okay, thank you. Good evening, good morning, or good afternoon. I am Minoru Koga, director at Minamata Environmental Academy, Minamata City. I think some of you have already visited Minamata City, Kumamoto, Japan, to join the conferences, workshops, or site visit here. It is a great honor to join a project on the survey and assessment of current status of environmental monitoring laboratories organized by UNEP, the regional office of Asia and the Pacific. And very glad to talk on overview of survey today. Next, please. Next slide, please. Okay. This slide shows objectives of the survey. Basically, such laboratory surveys should be based on on-site laboratory evaluations, but visiting the facilities nor the face-to-face meetings are very difficult because of the spreading COVID-19 infections around the world. Therefore, as much as possible, we decided to share the information by holding a written evaluation and web conference using the internet to evaluate the current status and abilities of the laboratory. Furthermore, this time, we tried to evaluate the laboratory capabilities through the real-time video shooting using the internet line and try to make recommendations for improving the analytical capabilities of the laboratory. Next, please. Next slide, please. As next slide, please. I cannot operate. Thank you. Procedures for the survey are shown here. We sent questionnaires to the target laboratories regarding present capabilities for the laboratory environmental monitoring activities. We have organized a first web meeting to discuss with the laboratory director and the staff on responded questionnaire and related inquiries of the laboratory. Before real-time video shooting, we have a rehearsal to check the internet connection and the capabilities of the communication instruments even through the inside of the building. Next slide, please. Okay. Two laboratories in Nepal were selected as the target institute for the first survey. Our expert team consists of those members, specialists for mercury analysis and laboratory accreditation and local coordinator in Nepal, Dr. Bhupendra Advotka. Secretariat take care of arrangements of well meetings so often, and HIS, a travel agency in Kathmandu office, staff supported internet connections for real-time video shooting. Next slide, please. Laboratory in Philippines, environmental research and laboratory service, which is belong to the Department of Environment and Natural Resources of Philippine government, was selected. Our expert team consists of the same member as for laboratories in Nepal. As a secretariat, Mr. Borongan, Asian Institute of the Technology, had arrangements for our web meetings and surveys. Staff from the HIS Manila office supported internet connection for video shooting of the laboratory. Next slide, please. We firstly asked the questionnaires on 47 items to understand the laboratory current capabilities. These questions are equivalent to the ISO 17025 laboratory evaluation, and I think that it took a lot of time and effort for all the laboratory members. So many questions. Next slide, please. A local coordinator and local staff bring a video camera to the laboratory and take a real-time image according to the scenario agenda shown here. Also, they took photographs of the detailed situation according to our request. Although the time exceeded 19 minutes, we were able to confirm that the situation of the laboratory in detail. Next slide, please. The survey result will be published shortly from the UNEP. This is my impression or just comments. To target laboratory in Nepal, not now, not currently conducting a Mercury analysis. However, both laboratories has enough capability for clinical and environmental examinations. If enough laboratory space for the Mercury analysis, analytical instruments, analytical techniques, and quality control procedure for Mercury analysis are introduced, the laboratory will be recognized that has a sufficient ability to analyze and evaluate the Mercury contamination in the environment. And our laboratory in the Philippines has excellent abilities for Mercury analysis. The staff are highly trained and have enough experiences for environmental Mercury analysis. So we are so glad if they could collaborate in the scientific community to develop Mercury monitoring technology in Asia and the Pacific regions. Next slide, please. So the advantages of online survey we could save time and cost. Also, we could spend much time to communicate with the laboratory staff. As the challenge issues insufficient internet environments on both sides, so sufficient rehearsal is required and time difference restriction with the local area should be considered. The role of the local coordinator is very important. Fortunately, we are able to smoothly proceed the survey because several members of our expert team were familiar with the situation in Nepal and the Philippines and had a close relationship with several laboratory staff. Okay, next slide, please. This is a snapshot of web meetings. I would like to thank all those people who collaborate with in this online survey. Next slide, please. Okay, next slide is the last one. So thank you for your attention, and thank you for Hayashi-san for your assistance for my talk. Thank you.
Thank you very much, Koga-sensei, as well from my side. We are looking at the chat box, so please, audience, put your question on your chat box, please. In the meantime, if panelists from our side, if you have any questions, please go ahead.
This is Nick Saito again. I just want to add, not add, but comment from the project side. So this the proficiency testing that for the first presentation can only be we can only assess the capacity for those laboratories that has already started the mercury monitoring or analysis. But this assessment is not limited for those laboratories that have not yet started, but they have planning for the future mercury analysis, so that we can differentiate these two purposes. Okay, so both assessment and proficiency testing are very useful too for knowing the level of the competencies. Thank you.
Saito-san, thank you very much for your supplementary information. And now we have one question on Koga-sensei's presentation from, sorry, my pronunciation, Ram Charitasa-san. And the question is, after establishment of these laboratories in Nepal, will it be available for NGOs and public to get access to be tested those samples? So what will be the future plans for the laboratories exercise in Nepal? Sensei?
Yes, we have learned that major mercury emissions and contamination in Nepal due to the dental treatments and gold plating works. Most of the craft gold plating works are on a small domestic scale and follow the traditional technologies. So I think some people or some workers of gold plating craft factory worry about mercury exposure. So they want to know how to evaluate such kinds of the exposure or contamination. So they want to bring hair or urine samples to check the concentration of such kind of the chemical as a biomarker of exposure. But still, they don't have enough technology to analyze the mercury in a biological sample. So that I think the two laboratory has each has a clinical examination is so nice, and others environmental samples, heavy metals environmental sample well trained. So I think it may possible they are now expanding the ability of such analytical skills and so on. So I'm not sure how to government decide, but UNEP will be give us some recommendation or some guidance. We already reported such kind of the activities in the near futures. Yeah, that's my.
Okay. So just I add on to the what Koga Sensei says that we assess this Nepali two laboratory in Nepal. They are the potential. They have the potential for the mercury monitoring, but at this moment, neither of those laboratory has conducted the mercury monitoring actually. So they didn't participate in the proficiency testing. So this intercomparability is also not yet assessed. So what we have learned in this study is that they have the potential, but we don't know they have already established laboratory. So we cannot say we don't yet have the answer about this that question because we are still don't know if they will become the very established laboratory in near future. We hope it, but are not yet sure.
Okay, thank you, Saito-san.
Thank you very much for your explanations, and thank you to Ram-san. And we hope we can continue discussions on the Nepali laboratory samples, and please stay tuned, and we are free to answer your questions via email. And we have another question from Mr. Bushra Afzal-san. And this is a question for UNEP, rather. This is about proficiency testing. Saito-san, will you be able to answer?
I will use the chat box to reply.
Okay.
Yeah.
Mm-hmm. Okay.
Maybe
Next.
ask Haraguchi Sensei also look at this question.
Mm-hmm. Okay, thank you, audiences. So we will provide you the answers on the chat boxes, and of course, we can continue conversation afterwards, after this seminar. So we move on to the next topic by Miss Kanya Dwi from Indonesia. So you have the floor.
Thank you very much, moderator. Good morning, good afternoon, and good evening, everybody. First of all, I would like to say thank you for the organizing committee for having me today so that I can share Indonesia experience in developing the Mercury inventory. And in the beginning, Indonesia utilized the UNEP toolkit for quantifying the mercury emissions and release to the environment. And this toolkit was developed by the United Nations Environmental Program, and we can find it easily in UNEP website. It is packed in a user-friendly Excel program, which is easy to learn. And the guideline which inform us how to use this toolkit is also available, as well as a template for reporting development. Next slide, please. The mercury inventory using UNEP toolkit only quantify the amount of mercury from the anthropogenic sources or man-made sources, while mercury from natural sources are not identified or quantified. And basically, there are two types of mercury from anthropogenic sources. The first one is the mercury impurities in raw materials, which will be unintentionally released to the environment due to the certain processes, for instance, combustion of coal in coal-fired power plant. And the second one is mercury used intentionally in products and processes, such as in artisanal small-scale gold mining, as you can see here in the figure. Next slide, please. And the basic calculations of inventory toolkit is very easy, as presented here in the simple equation. The estimated mercury release to the pathway X equals to the activity rate times input factor times output distribution factor for pathway X. And X here means release to the air, water, land, impurity in product, general waste, and specified treatment disposal, as you can see in the lower part of the slide. And the activity rate represent the magnitude of activity which releases or emits the mercury. For instance, here the amount of fuel such as coal or oil combusted within a year, a certain period of time. And the input factor estimate the amount of mercury release from activity. In our case here is gram of mercury release per ton of combusted fuel. And the output distribution factor estimate the fractions of released mercury which goes to certain pathways. Next slide, please. And this UNEP toolkit is available in level 1 and level 2 version. In level 1, the estimations of mercury emissions and release use the default input factors and also default output distribution factors, which have already been given within the toolkit. While in level 2, the input factors must be determined based on the country-specific data. And if possible, we can also revise the value of output distribution factors based on our country-specific data. And we will have more accurate estimations if we use level 2 version, since we develop in the estimations based on our local condition. Next slide, please. And Indonesia has already done the mercury inventory so far 3 times. The first inventory was conducted in 2010. And our second inventory in 2017, we applied here new versions of toolkit, and there had been some changes within the toolkit, especially some of the default input factor values were updated. And our latest inventory was done in 2020 using the latest versions of the toolkit. We tried to improve the level of the inventory for some subcategories because our previous inventory only used level 1. And of course, in this stage, we face challenges of developing specific input factors and also output distribution factors due to very limited data of mercury measurement in our country. And in 2022, we tried to improve our inventory by trying to develop the mercury mass flow analysis, which I will explain later on. Next slide, please. This is the result of our first inventory in 2010. As you can see here in the figure, the main source of mercury came from the ISGM, artisanal small-scale gold mining. which was responsible for about 57.5% of the total mercury emissions and releases. And most of the mercury were emitted to the air, or more than about 59% out of the total amount of mercury emissions and releases, as you can see here in the figure on the right-hand side. Next slide, please. This is the result of our second inventory in 2017, which used different versions of the toolkit, level 1. And the gold extractions with mercury amalgamation, or ISGM, was still the main source of mercury emissions and releases to the environment. Next slide, please. In 2020, we tried to develop the inventory level 2 by gathering many information related to the activity data as well as mercury measurement to calculate our own specific input factors and output distribution factors. This is the example for coal combustions in coal-fired power plant, where we try to develop the input factor from the point sources data, as well as the type of coal use, and also the type of air pollution control devices, which is installed in coal-fired power plant. And we also gathered this information from the local coal-fired power plants in Indonesia. Next slide, please. And for the artisanal small-scale gold mining sector, we tried to develop our own specific input factor and output distribution factors using some mercury measurements data, which were taken by applying another UNEP toolkit, which is called for estimating mercury use and documenting practices in artisanal and small-scale gold mining, as you can see here in the tables. So there are various data from various places, and then we gather the data and calculate to derive the specific input factors as well as the output distribution factors. Next slide, please. And here, our latest result of inventory level 2 in 2020. The primary metal productions category responsible for mercury input to society. And we can also see a subcategory breakdown for this primary metal productions in the right-hand side figure, where we can clearly see that the ISGM still gave the highest contributions to the mercury source. Next slide, please. This figure illustrates the mercury releases to 6 pathways. And as you can see here, still, the ISGM responsible for the highest release of mercury to the environment, especially to the land, to the water, and also to the air. Next slide, please. In this slide, we can see the UNEP toolkit source category, as the main source of mercury release to the environment are well documented or well determined from various sectors such as energy, metal productions, intentional or unintentional mercury use, consumer products, and also waste handling. So this toolkit is actually suitable for illustrating the highlight of mercury emission release in national level, but unfortunately, it cannot reflect the detail of mercury flows between these categories. So there are also some missing links related to the input and output to the system, because we cannot identify the import and export activities within the toolkit. Therefore, some improvement are needed so that we are able to see the connection between these categories one to another. And in this case, we are able to see the amount of mercury flows between them, between these categories. Next slide, please. This slide tries to illustrate how we develop the mercury mass flow analysis based on the previous inventory data using UNEP toolkit. So we mainly use UNEP source categories. For example, here we can see part of our built MMF figure in the right-hand side. consists of domestic product with and without mercury in the upper left side, and then general consumptions of product containing mercury in the upper right side, and the waste treatment and management in the bottom part of the figure. We are also trying to develop the connection between each category, so we can see directly how mercury flows from product use, and finally to the waste handling. Next slide, please. In this slide, we are able to see our current result of mercury mass flow diagram. And of course, this is still not perfect yet. And the amount of mercury flow here is neither complete nor accurate yet, actually. It's obviously, we still have lots of things to do for completing this MMF diagram. And as it is mentioned before, that we are trying to develop the MMF based on the source categories specified within the UNEP toolkit. We actually found some difficulties, especially in regarding how to connect between subcategories and arranging them in more organized figure. So in the figure here, you can see basically 5 different categories. We try to describe in 5 different major colors. The red arrow here describes the emissions and release of mercury to the environment, to the air, water, and land. At the bottom of the figure, you are able to see the amount of mercury expressed in blue color, which means emitted to the air. The red color means related to the water, and the green color means related released to the land. And the black arrow shows mercury flow between subcategories, as well as the import and export activities are also included. The first category is related to the extractions of energy, such as fossil fuel mining in coal, oil and gas, and other natural energy source, such as geothermal. Indonesia is one of the main coal exporters in between Asian countries, but somehow we also import crude oil to be further refined in our country. And during the extractions and refining of oil and gas, some mercury is captured using certain technology, usually using adsorption technique, and the captured mercury is stored and then exported for further handling and treatment. And the second category is the use of energy, especially in large power plant, industries, transportations, and also households. From these activities, mercury is released to the environment, as well as goes to the waste management facilities. Mercury also flow from household to the wastewater treatment plant or waste incineration plant, as well as to the waste landfilling facilities. These facilities also receive mercury from several subcategories, as illustrated in the figure at the above part of the slide. And the third category, we call it here as industry. It is actually consists of primary metal production, such as ISGM, is also included in here. And then productions of other minerals and materials, which mercury impurities, such as in cement, productions and pulp and paper productions. Also, the intentional use of mercury in industrial processes, such as in chloralkali productions with mercury technology. And mercury from this category can be emitted to the environment, and if there are particulate control devices, the collected and particulates which contain mercury will finally go to the disposal facilities. And you can see here they're also connected by the black row here. And the fourth category here is the consumer product containing mercury, and most of the used product go to the waste deposition facilities. Many import and export activities are also involved in this category. And last but not least, the fifth category is the waste treatment facilities, which receive liquid or solid waste to be further treated, incinerated, or deposited in a landfill. Next slide, please. And from our experience during developing this MMF diagram, there are some challenges in collecting data, especially such as lack of data of mercury content within materials, products, and also waste, except in cement industry with alternative fuel and raw materials, and also in coal-fired power plant, because we have detailed data regarding the mercury flow in cement plant. And also the mass balance of mercury in coal-fired power plants, as I mentioned before, that we also develop specific input factors for our coal-fired power plant. And however, we are still lack of data regarding mercury content in municipal waste. And this data is difficult to determine, since various types of waste may also have various mercury content. And also information of mercury content in the medical waste is really rarely to find. Basically, it's not available. And data of mercury content in emissions and release are available only from certain industries where their emission standard and effluent standard have been specified by the certain regulations from the government. Therefore, these industries or subcategories report their mercury content within emissions and release regularly to the government through the Ministry of Environment and Forestry. So data from these subcategories can easily be derived. And in order to have more information regarding data of mercury content within emission centers from other types of industry or subcategories, the information should be separately gathered, for instance, using questionnaires or other reliable systems, because there might be some industries which actually have measured the mercury content for certain purposes, such as knowing the impurities in input materials to the process. And this is actually common to be conducted in the oil and gas industries or metal ore mining. But unfortunately, until now, no questions have been distributed to the relevant stakeholders for gathering this mercury content and information within materials, products, and waste. This is actually one of the easy way in gaining data, as long as this activity is conducted by authorized parties, such as Ministry of Environment and Forestry or Ministry of Industry in Indonesia. Another main key data gaps in developing mercury mass diagram is the lack of mercury content within imported and exported products. There should be certain HS code or harmonized system codes. This HS code should also contain the information of quantity of mercury within the traded product, so the customs authorities all around the world are able to identify mercury containing product easily. And then difficulties in gaining information sharing among government institutions regarding mercury, difficulties in obtaining the mercury stock from related industry, and also last but not least, obstacles relating to the regulation phobia, where industry or related activities in providing true information related to the mercury content within their activities. Next slide, please. Okay, this is the proposed key action plan for data collection. So in the beginning, we have to develop a roadmap for data collections, because a roadmap is a strategic plan that define a goal or desired outcomes and includes major steps or milestones needed for data improvement. And we also have to promote intensive approach and communications with relevant sectors, because there might be data which actually have been available and haven't been collected yet from the relevant sectors. In the same time, you also have to concern about the confidentiality of the data and communicate in such ways so that the data source shall not hesitate or being afraid in sharing the data. And involving the government offices in the province or local government are also very important, because they are also the one who know the situations within their territories. Developing systems which may continually collect and improve data in this also important, because in this way we are able to determine the target and achievement which can be derived in the future. And then strengthening capacity of National Analytical Laboratory for Mercury Analysis to support Mercury inventory plan is also very important, as addressed by previous speakers. And developing Mercury inventory led by a government institution like Ministry of Environmental Forestry, or other government institutions like Ministry of Energy and Mineral Resources, Ministry of Industry, Ministry of Health, Ministry of Trade. Also very important. And then open to the international aid, especially for developing countries like Indonesia, is also one of the important actions plan in improving data collections. So as in summary, the government of Indonesia right now or currently trying to accommodate this key actions plan. So we are now in stage of continually improvement our Mercury inventory. I think I have come to the end of my presentation. Thank you all very much for your attention. Thank you.
Thank you, Dewey Sensei, and it was a very interesting presentation. And also, thank you to the audience for lively discussions. Just to pick up one question for Dewey Sensei, there was a question about gold plating practices with monasteries. And do you have any data in Indonesian perspective?
Excuse me one more, please, because I think I lost the connection.
Sorry, you repeat the question again.
Yes.
Some interesting discussions are going on the chat box regarding gold plating practices with the monasteries mainly. And we assume that Indonesia also has some practices, similar practices. So do you have any information on that from Indonesian perspective?
Excuse me, according to, I still cannot get your word, keyword.
Just read out exactly what it's written.
Which one?
Okay. The question
from
is from
India?
Ram-san.
From who?
From Ram-san.
Okay, I will read out. As in
Okay.
Indonesia, a lot of temple, monastery, and mosque might be having a gold plating artifact
Okay.
depicting
I
metal
see.
idols in these places. Yeah. Have you had any mercury-based gold plating process ongoing in Indonesia?
Okay. Have you find any mercury-based gold plating processes ongoing in Indonesia? Mercury-based gold plating. I think it's right now we haven't have information yet about the mercury-based gold plating, especially in monasteries and mosques, because it is not included in our previous inventory yet. But we can also develop or add this category to our inventory category. I think it is also a very important source for the mercury releases. But right now it hasn't been any information related to this yet. But it is correct, there are a lot of temples and monasteries and also mosques available in Indonesia, because there are various religions in our country.
Thank you. Thank you for your additional comments. Okay, good. We're sorry to rush, but we are going to come to the last presentation from Saito-san, and as we can continue discussions on the chat box. So Saito-san, you have the floor.
Can I start?
It's yours. Yes, please.
Okay. So thank you very much. So maybe this is the last presentation. Not directly implemented by the project, but the project did use the existing data survey that done by Ministry of Environment in Japan in the past few years. Based on that, we make some assessment, analyze the data information. This is about the mercury, the solid waste disposal facility, the behavior of the mercury in the solid waste, especially for the open dumping site. So we okay. Next slide, please. Next slide, please. Yeah. So this is the diagram for the global mercury flows and stocks. So right-hand side, we have the natural circulation of the mercury, emission, deposition, and also they have the a big stock in the ocean and in soil. And if you can see the right hand side, we have the mercury sink. Sink means buried into the deep seabed. So because the mercury existed since the Earth is created, so this is referred from the man-made chemicals. This is the long history of the mercury circulation naturally. So they have the mercury source as well as the mercury sink in the natural world. On the left-hand side, this is the man-made artificial the circulation. The human society excavated the mercury and put in our society. We produce and then dispose. And the mercury waste is something that this mercury to return to the earth. So this is the possible if the mercury final disposal is stable, it can work as the another mercury sink. So this is the important meaning of the mercury waste management if we can use it. So okay, the next slide, please. So this pie chart is the result of the mercury global mercury assessment in right-hand side, and the global mercury supply, trade, and demand left-hand side. For the mercury use, the ASGM is the biggest. The mercury emission to air on the right-hand side, also ASGM is the biggest. So it's similar, but the other component, if you read through it, it's a completely different, pretty different. For the use of the mercury left-hand side, it's the processes like the BCM production or chloralkalies, or the mercury added product like battery, dental amalgam, measuring devices. But for the mercury emission in the middle top, this amount is mostly the fossil fuel burning, metallurgy, cement production. So this is the unintentional emissions. So this is the difference between the mercury use and mercury emission. So maybe the next other slide, please. Then if you think about the this mercury use and mercury emission releases, so the most of the mercury use, like for the mercury products, mercury catalyst, electro, will be end up with the mercury waste. So mercury waste is something that that all receiving this kind of mercury usage and putting the landfill or whatever. So if you compare the size, this size of the pie chart is proportional to the actual volume amount. So comparing the input side for the mercury use, mercury emission side is pretty small comparing the size of the use. It means the bigger chunk of the mercury is not emitted to the air or not released to the water, but it keep in the somewhere is stored in the mercury solid waste landfill location. So that this is the reason that we want to know the behavior of the mercury in the landfill site. Next slide, please. So they have the two typical mercury or waste management practices. Left hand is the waste incineration. Right hand is the open dumping. So we just want to compare these two waste management practice in terms of the behavior of the mercury emission release and so on. Okay, so the next slide, please. So the firstly, we use this the existing literatures such as the mercury global mercury assessment and the table up above table, and then a mercury inventory toolkit, the table below. These are the output distribution factors that are percentage or portion that this mercury will be, and that with any particular environment media. So the mercury emission factors in maybe the next slide, please. Mercury emission factor for the waste installation well control. This emission factor is 0.1 on the top side. The uncontrolled maybe the bad installation, its emission factor is 0.9. The landfill well managed emission 0.5, and landfill unmanaged about 0.1. So it means that good waste incineration plant and landfill has the similar emission factors. But for the bad or uncontrolled emission waste incineration, emit the mercury much higher than the landfill unmanaged, mean the open dumping mercury the landfill site. So this is the nature of the mercury in terms of the emission to the atmosphere. Okay, thank you. Then the next slide, please. Then if this is the just you can see the mostly the no emission reduction device the table below the installation with the no emission reduction devices emission output factor is 1. Open waste burning, open burning is also 1. So the same. So the incineration with no emission reduction devices is equal to the open burning of the waste. So it's a very bad practice. And for the landfill, informal dumping, maybe the right hand end, even this informal dumping with unmanaged bad practice, but still the this 80%, 0.8 of the mercury will be kept in the land. So only the 10% will be emitted and the 10% released to the water. So 80% still stays. So this is the what mercury inventory toolkit says. Okay, next slide, please. So we have referred to the MOEJ survey. They have the 5 countries, the 5 landfill sites from 5 developing countries. And facility A and B has the generated gas, a digested gas control system. But the C, D, and E has no system, and open burning and spontaneous solid waste combustion occurring. So these 5 sites is the survey site for the MOEG survey. Okay, next slide, please. Then just a simple refer to the result. This these two graph shows that the ambient air concentration in the 5 sites A, B, C, D, and E. So blue bar indicate the average for the about 3 hours, and the yellow line shows the 30-minute average, 30-minute values. So if you can see the this 30-minute value is very significantly fluctuated depending on the wind direction, on the spontaneous combustion, open burning of the west. So it's not very stable. But it is important to know that WHO standard is 1 microgram per cubic meter. So if you see the yellow or chart, one microgram is the 1,000. So it's a red line on the top. So any data exceeded these values, it means that this concentration level, it's not the level that maybe we need to have the health concern for the worker on the landfill site. Okay, next slide, please. So this is the analysis for the total mercury and methyl mercury in the human hair, the workers and the neighbors. So in this, the methyl mercury and the total mercury, if you compare the values, mostly this is the very similar value. Means that most of the mercury in hair is actually methyl mercury. If it's a methyl mercury, it comes from the diet, not from the external exposure from the kind of the atmosphere. So this is the also the confirm that the ambient air in the landfill site, it's not kind of a significant health hazard for the worker on the site. Okay, next slide, please. Yeah, but a couple of 1, 2, 3, 4, 5 people had the extremely high total mercury concentration. Maybe it is that maybe have caused by the accidental exposure to elemental mercury or mercury compound, or they are using the mercury added maybe the creams or soap, or that's reason that why they have the extremely high. But it's not all the workers in the working at the same location. So this is not. I assume that this is not because of the ambient air that should cover everybody. Okay, then yeah, next slide, please. I just want to skip this one and get to the some summary. So if you compare that kind of result, then for the emission to air incineration plant, it's the equivalent or even higher, even though this got well managed the site. And also the open dumping site, it is concern about the human health, but at least for the environmental atmosphere, mercury from mercury, it's not the level that human health is of concern. But the uncertainty is the open burning, spontaneous combustion that may emit the significant amount of mercury. So this open burning is really concern about the open dumping site from the mercury perspective. Okay, next slide, please. So this is just the simple survey, but this kind of a report we made available by UNEP project website. So please keep make some reference for your benefit. Okay, thank you very much.
Thank you, Saito-san, for your presentation and interesting information about dumping sites. And dear audiences, we are slightly running behind the schedule, but we are still open to some questions. And so we haven't seen any questions about the dumping sites, but if you have any, just we can stand by. So please go ahead.
Maybe I can reply by a chat box if you have something that need to.
Okay, that's a good idea. Thank you. So I would like to provide you one chat information, and that is our questionnaire. And so please give us your feedback on our post-training evaluation questionnaire. I have just put the put in the chat box the link for the questionnaire. So please visit the site and give us your feedback. Okay, and after this session is over, in fact, we still keep open the chat box for a few minutes. I guess we are okay with that, so we can continue our discussions. And thank you very much indeed for all presenters, panelists, and audiences for your lively discussions. And I will hand over the microphone to Toda-san for closing remarks. Thank you very much.
Thank you, Yayoi, and thank you very much for all the presenters and organizer in the pro-op. I think this session was very interesting, useful to assist us in the implementation of the Minamata Convention, and I regret that we don't have time to cover all the uh, uh, questions in chat box that are very interesting. I think you can put your still put your question in the chat box, or perhaps when you receive the questionnaire, you can put your message. So I think we covered the very important scientific topics of monitoring and emission inventory that are very important in terms of the implementation of the convention and also the evaluating the effectiveness of the convention. We very much look forward to working with all the scientists, experts in supporting the implementation and effectiveness evaluation. And I think this workshop was a very good opportunity for exchanging information. So with this, I would like to close this Minamata online session. Thank you very much, and see you all in the forthcoming season 3. Thank you very much.